Okay, so this is a video about testing doing two-tailed interval tests on a proportion. Um, so in problem number one here, we have Gwen is heard that 80% of the students at Garrison Forest School are above average. So in part A, we had to create the two hypotheses, the null and the alternate hypothesis. So this is a claim about a proportion, and it's a claim of 80%. So it's an equivalence statement. So the alternate would be that it is not 80%. Okay. So there's my two hypotheses. And actually, for all of the problems in this worksheet, it is a two-tailed test because that's what we can do here, right? So this is a two-tailed test. Part C. All right, so part C is based on some information that we're given here. The Gwen actually goes and takes a sample of 50 students and found that 42 of them were above average. So at this point, I want to reach for my calculator. Okay, so I have my calculator out. I'm going to do a stat test, and I'm going to drift down to letter A. Nope, sorry, stat test. There we go. Drift down to letter A, which is the one proportion Z interval. The number of people who were above average were 42. The number in the sample was 50. We're calculating a 95% confidence interval. So there is my interval. Okay. So I'm going to write that down back on the other screen. Oops, sorry about that. And then we'll continue. So let me pause and get back to the other screen. Okay, so the confidence interval that we got from the calculator was 0.73838 to 94,162. So when I look at my null hypothesis, it says that the proportion is 0.8, which is actually on that interval. So I fail to reject the null hypothesis. And since the null hypothesis represents the claim, I can say that Gwen's sample, Gwen's sample supports the claim that 80% of GFS students are above average. All right, so looking at problem number 2, this is also a claim about a proportion. It's a claim that 30% of likely California Democratic voters will vote for Joe Biden in the 2020 Democratic primary. So the claim is about a proportion, and it's a claim that the proportion will be 30%. So that's my null hypothesis. My alternate hypothesis will then be that it is not 30%. Part B is that this is going to be a two-tailed test because it is a not equal statement. And then in order to do part C, I need to use the calculator and I need to look at the sample data that I have there. All right, so I'm doing a sample here. So I go stat tests. I go down to letter A, the one proportion Z interval. I have that there were 104 people who have the characteristic of voting for Joe Biden, and that the sample size was 400. I'm doing a 95% confidence interval. So there's my confidence interval, 0.21701 to 0.30299. So we're going to transfer that over to the other screen. Okay, so C gives me 0.21701 to 0.30299. So 30% happens to be on that interval. So again, we fail to reject the null hypothesis. Part E tells me, well, if I fail to reject the null hypothesis and the null hypothesis is my claim, then we say that the sample supports the claim that 30% of California Democratic voters will vote for Biden in 2020 primary. Okay, so there you go. That's problem number 2. Let's move on to problem number 3. All right, so we have a marketing director for a corporation that makes a claim 35% of consumers will prefer their product over a near competitor. So H null is going to be 35%. HA is going to be that the proportion is not 35%. That's 0.35, 0.35, right? Okay, so part B, again, because it is a not equal situation, will be a two-tailed test. So let's get to part C, which is the part we need the calculator for. All right, so let's start a new test here, right? So let's go down to A, 1 proportion Z interval. All right, so the number of people who prefer our product to the near competitor, according to the sample, is 30 out of 150 who were asked. So let's calculate that interval. All right, so the interval is telling me it's like between 13.6 and 26.4%. So let's go and transfer that over to the other screen and see what that looks like. All right, so from the calculator, we got that the confidence interval is 13599 to 0.26401. Right? So if I look at that, that 0.35 is not on that interval. So I have to this time reject the null hypothesis, right? So if I reject the null hypothesis is the claim here. I have to say that the sample does not support the claim that 35% of all customers prefer their brand over a near competitor. That claim is pretty much not supported by the data. The data says that the actual proportion has to be between 13.5 and 26.4. The claim of 35% is definitely not supported by this data. All right, so let's look at problem number 4 here. Problem number 4 says the claim is that the Orioles will win 50% of their games this year. So I don't think they're going to be playing any games this year, but that's okay. The null hypothesis here would be that the proportion of wins is 50%. The alternate hypothesis would be that the proportion of wins is not 50%. And again, we know that this is a two-tailed test. Okay, so let's break out the calculator and look at the data. Okay, so we want to get a one proportion Z interval, so that's down here at A. So far we have that they have won, what is it, 15 games out of 36 with 95% confidence. There's my interval from 25.5 to 57.7. All right, so let's carry that over to the other screen. All right, so part C here is that we go from 0.25562 to 0.57771. The 0.5 is definitely on that interval, so we fail to reject the null hypothesis. Since the null hypothesis is our claim and we're failing to reject it, this sample supports the claim that the Orioles will win 50% of their games. All right, so there you have it. There's my solutions to the two-tailed interval problems for proportions, and I hope you're well. If you have questions, make sure that you bring them to the drop-in session. Thank you.